Hello and welcome back to another devlog. This one is number 16 and we got a lot done this week. So on Monday I was working with the project trying to get through some of these errors with the build manager. This is the first time I've actually sat down and tried to build the project because you have to test with the build because it's a little different than just working in the editor. So it's good to have a build at this point, and my plan is to do a build, say, every time I check back into main, just to be consistent to make sure that it's working. So since it was the first time, a lot of things are out of order and there was some errors going on. I couldn't figure out what was happening. Something was fighting with it. The editor was trying to import packages at the same time. It was doing a build and it was failing out. So I spent some time tracking down issues by pretty much chopping up the project and removing a bunch of packages and tearing it down until the errors went away and I could do a build on some level, and then kind of isolating the problem and building it back up to its original state until everything was sorted out. And I was trying this and trying that. It was a bit of a challenge, but I eventually got it working for a basic Windows build with the controller, and that's great. So then I moved on to trying to get a VR build, trying to actually push the build to the VR headset. This was the first time, so I wasn't sure. I was researching, and there's something called side load where you can go switch over to the Android platform and build an APK to push to your headset. Now, when I was doing VR, I was like, oh, you have to do Android, blah, 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 but nobody told me I had to figure this out that, yes, if you want to if you're designing an app as a standalone to run in your headset without being connected to the computer, without a Quest link where the computer's not rendering it, yes, you have to build an Android APK because the headset runs off Android, and that makes sense. But during the first build, I was able to build an APK, and I was able to push an APK build to the headset via sideload. It's interesting they don't have a native, Meta doesn't have a native APK loader, but anyway, it's the third-party sideloader app. Pushed it, and it wasn't working for some reason. It was rendering weird in both eyes. It was like a diagonal. It was like eye strain, like closing one eye, the rendering was like diagonal and upside down, and the graphics were like really diminished. So I was like, wait a second. So I unplugged the Quest link and it still runs. Like, okay, figure out this is not what I want. This is actually a standalone app. Like, we don't want that. We want something that's running on the PC and that's streaming over the Quest link to the headset. So it's being processed by the GPU. And so what I did, I just tried to implement in the scene just a basic Windows build and implement the setting for a third-person camera with a head rig, XR rig tracking, and build that, and then run it like a normal Windows build, but run it while Quest Link is plugged in, and lo and behold, it just pushes to the headset and works as expected. A build that pushes to the headset and everything's working fine. The graphics look great, or it renders fine. I don't have to mess around with what are these Android settings, whatever is going wrong with the rendering. I don't need that. It just works right and correctly in Windows. So that's problem solved. So you can use the normal controller and the XR rig controllers as well. So that was Monday. On Tuesday, I was working with things, and I figured out a couple things in the actual project settings. If you go down to the editor here and say, when entering play mode, it's usually set reload domain and scene. Now this, the hot reload cuts down the time, but it's only a good tool in certain use cases. If the app is currently running and you're making a change that doesn't change anything like interfaces, if it's just like an inline change, that can save you from having to restart the app. But the problem still remains when every time you, like if you're changing an interface or you're changing something that runs code in initialization for one time on the first run, if you're testing that, you still have to go through play mode every time. And what's happening is it's always reloading the domain and the scene every time you play that. And I had one file in here in the XR package. It was calling some editor file, and it took like, every time you play, it takes like 10 to 20 seconds just to reload this one XR interaction toolkit sample file that you're not even using, right? So I got rid of that, and it actually, you know, it sped it up. So that's 10 to 20 seconds multiplied by however many thousands of times you're going to hit the play button. So optimizing that, and also not reloading the domain or the scene every time you hit the play, so you can really get into the app faster and test this, test a lot, iterate a lot faster. You don't have to wait like 30 seconds each time you hit play. So that's great, but it also comes with some caveats. You have to like manually reload. You have to know when to manually reload. Control R is my friend now. I also moved over to manually saving, so Hot Reload was having issues. I think, you know, every time you make a change, it would save, and it would, you know, it would not. So manually saving and switching to a new system, manually saving makes Hot Reload a little bit more consistent. So with those changes, it speeds up the project development, but it also had an issue later on down the line that I'll describe. So I did some project cleanup, and then I went to working on building the actual game UI here, starting with the game UI. So this is a Reach UI package that I purchased, so it has pre-made UI, and so I'm using this as a framework, kind of like in Vector, and I stripped out a lot of the unnecessary UI components that were in here and just kind of made it like a base start screen. And I started exploring the framework that they're using, the package. So it's pretty straightforward. Took some figuring out, but it's much less complex and vast than in Vector. So I eventually figured out how to get an interaction point to actually start from, to actually load my scene that I've been working in. So for the scenes, you just have to have it enabled and build for a file, and then you can load those scenes. So I worked with loading different scenes before, but this is the first time I'll be loading different scenes and carrying over a game manager from scene to scene. So I'm working with that in depth, and actually, yeah, it's like I learned the basics, but now I'm getting into the actual advanced behavior of how the Unity system behaves when you're switching around scenes, how, you know, what data is carried over, and all the little peculiarities that I'm learning about and understanding along the way. So at the end of the day, I was able to do a basic scene load, implement that, and just starting with the game manager. So moving from a basic game manager and adding more logic to make it more complex to handle the transitions of states from, say, the start menu state to the actual in-game state. So it's kind of nice UI, has nice sounds, effects, and transitions and such. So this is just base placeholder. I would change all the images and maybe the sounds and stuff, but this is just the framework that, you know, that allows me to get into the game and load the first level or chapter of the game. So interacting with this button, we have a rough just a load, so a hold, a non-asynchronous load. I'd want to have some sort of loading screen in between this as an intermediary, but interacting with that button, it will load the scene, and you're in the game. So just working through a lot of bugs on Wednesday. Working with scene loading, and let's see. So I was moving on next to implementing a pause screen, and that's when I kind of hit an issue where the pause controller, it's actually reading from UI or the input action system, but a different one, like a default system. So the interesting thing that I found a bug where it's like you run the game once and then you run it again, and then all of a sudden the player input stops working. And so what's going on here? Well, I had kind of strayed away from my initial implementation. I learned to a more novel approach using scriptable objects for player input. The only problem with that, when I moved to the do not load domain, reload domain on each play, that's how it stops functioning. The input SO needs to be reloaded on every time you play, and that wasn't going to work for me. So looking at the actual pause screen input, I noticed that it's working the way it should. You know, every time you play without reloading the main, it'll still function correctly. So I sat back down and actually refactored the player input to use something that I had originally implemented, where it's using a player input player input component to actually listen to input events, and then I have my input manager subscribe to those events and such. So I cleaned it up and went back to the original system. I don't really need the scriptable object implementation for this, especially if I'm going to be testing without reloading domains. So I got that working on one input actions map for both UI, context, and player actions control. So now the pause menu works. What else? So working through issues during the refactor, I completely, along the way, I completely removed all the legacy input that Invector reads from, and I had to kind of comment out a lot of code in the Invector system to make sure nothing's reading from legacy that it can't error out and make it stable. So at this point, I've pretty much given up on the prospect of actually ever updating the Invector framework with new features. It'll just have to be how it is. Like, I could update it if it really was a good update, but at this point it would just be as it was when I first downloaded it, and that's fine. Like, because I've had to make so many changes to it, it would be a lot of work to actually apply updates and do a merge on the Invector framework. So with that in mind, I'm still going to do wrapper classes. I don't want to just go in there and modify the Invector system directly. Same thing with any other framework. I'm going to try not to modify it directly, but there was an issue with one of the Reach UIs. I wanted to change the behavior, and it didn't. It was simple enough where it didn't allow for easy extensibility. I couldn't build a wrapper class on top of it just to change one line. So I just said screw it and just change that one line, and that's kind of my attitude. I'm not gonna go the extra mile unless I have to build a lot of functionality and a big system on top of another framework like Invector. So if I just need to change something, I'm not going to fuss over it. I'm just going to go ahead and make those small changes and not really count on having to update in the future. It's just a bit of tech debt that I'm willing to accept. So I got the input looking good, how I want to, and so the rest of the day on Wednesday I was just working through issues of the pause screen, Things like when the combat music's going on, when you hit pause, it'll actually stop the music. Other things like when you hit pause and you hit like the shoulder button, the game actually pauses automatically. I didn't have to implement that, which is great. But if you hit like a player interaction button, it'll actually play the sound, and then when you unpause, it'll cue that action later. So I wanted to disable all player, go in there and block all player input when the game manager pause state is active. So just working on the game manager class, fleshing out a lot of logic for the game manager to handle different states. So we have the pause menu state, we have the in-game state, we have the main menu state, and then I think finally we had the last one, we had the game over state. So on the pause menu, I had this free framework. It had a cool transition, but the problem was it was actually rotating the camera to face another position instead of rotating the UI around to face the front camera. So I just decided to use Reach UI's pause screen. It's good enough and it looks good. It's pretty clean and functional. Plus it works with the Reach UI system. It just wasn't worth actually using that other free system. The code wasn't as solid and robust, and I'd have to integrate a lot of stuff and mix a lot of stuff. It just wasn't worth it for the simple UI that kind of rotates around when you interact with it. It was cool looking, but it's work for not really big payoff, so not really big value in there. So I decided to go with this one, and it's perfectly well. It's perfectly good. So. Yeah, it has cool stuff that I can fill out later, like, you know, all the settings and stuff, and then all the other things. So let's see. On Thursday, I was a bit distracted. I had an actual interview with a client about a job, and when that happens, I always get anxiety leading up to the interview, so I can't really focus on coding. My head's somewhere else. You know, just got to get back to emotional stability to actually focus on implementing the game. But I did get some work done, and I was working on fixing issues, going from the actual start screen, doing some regression testing, going from the actual start screen to see how quick it starts up now. It just boom, you're right back in the game. It doesn't have to wait. It doesn't have to reload the domain every time. You're right back in it for testing. So I was just regression testing. You know, there's some issues surrounding, you know, when you're going from the main screen to the actual game, the actual state of things. I was learning about the Unity system behavior, specifically switching from screen to screen that I hadn't accounted yet. Like, if you're doing a get component, it won't actually return anything if the component's inactive. So a lot of things I hadn't considered, and just learning a lot along the way. Learning how to leverage the hot reload tool more effectively. Hot reload, like I said before, it's good for certain cases if you know how to use it properly, like you're in the game and you're maybe changing some code that's running actively on the update loop, and so you don't have to actually reload the application just to make that one change. But other than that, you just kind of want to keep it off and manually reload, manually save when you have to. So next, I actually implemented a player debug functionality to actually cause the player to die, so that it could send off another. I created another event. On Thursday, I took another crack at actually implementing another enemy, like another event kind of thing. It says two of them. I have to make a note of that. But I just noticed that it's two of the same events. But anyway, do another event that. So when the player dies, it's going to send out a global event, and now the game manager is going to listen for the event and actually take action to switch the scene and push the game over credits screen. I took another crack at actually making this little component actually have multiple different. You can actually do multiple different events, channel listeners in one component. But it was beyond my knowledge and understanding. Because it deals with generics and stuff, and the inspector just doesn't like it, just can't handle it. It didn't matter what I tried, I just could not get it to work with Odin Inspector, so I eventually gave up. Like, if I want to do another event, I just have to do it in the standard way and have it one event per monoscript component, and that's just the way it's going to be. I've seen other ways, like Invector has one, but they're not using like SO object for event channels. They're actually using just hard-coded strings that match. And in that case, you can actually do a list like that. So that's just the way it's going to have to be. I can't find a free tool that actually does what I want. It's a low value one that I was spending too much time on, just trying to take another crack at it. That's really not, it's good for tool organization, but I just couldn't. It was just too tough to actually get it to do what I wanted to with Odin Inspector. So I moved on after Thursday for that. So now we have the enemy death debug actions. So now I can actually, let's see here. Oh, I have to. There we go. So on the enemy death event, the game manager will listen. After a couple seconds manually waiting, it'll initiate a load of the scene. So we're back to the main menu scene, but the game manager is configured. It's controlling a lot of components in the canvas. And depending on the new event, the new state, game manager state, game over, it's going to control which UI canvases are active for the state. So it's going to start on this credit screen, and when it's done, it's going to go back to the main screen. So that took a lot of work doing, but that's a full regression, or that's a full cycle framework of game management from start to finish. The event that ends the game, and then going back to the main menu. So that's a framework to work on, but it took a lot of regression testing from start to finish, from the start screen to make sure you could do full cycles and everything's working good, and a lot of logic to manage the different game states going from the start to finish. So got that, we're looking good. Obviously, I'd like to have some sort of intermediate loading screens happening, and maybe a death screen to say, do you want to restart? Something like that in between, but this is the start to finish loop. So that's all working good. So I spent the last half of the day on Friday starting to look at the final feature of this Systems Epic. And what I have to do here, I created a basic testing scene to kind of prototype what I'm looking to do. I have this theory and this idea of what I want to do, looking at a bunch of stuff. So there was this tutorial here that kind of demonstrated how to use something like this. So in the basic properties, you have just your direct property, like a float here. What you want to have, so the goal here is to actually be able to call a function that saves all the relevant data of the state, and then it can actually load that data back into the object when the play app plays. So in order to facilitate that, I needed some sort of mechanism that that we can capture that relevant data in the form of that data in a scriptable object. Now, so what I can do here, so I made these in vector components that kind of allow you to switch between, if you want to use the direct, like a value, like a normal value like this, or you want to actually run it off of loaded reference data that could be persistent, right? And buttons to say, okay, when this component starts, load the data from the scriptable objects into these inspector properties to be used during runtime. So fine-tuning the original implementation, adding buttons like where you can actually, from the value, you can actually set the value to the persistent SO object or reset the SO object to the value. I have actions where you can actually, for a property where it's actually not used directly, like I want to set the position to the transform, you can override the action and say save, so it'll save this position data to the actual. Let's see if I can actually run this. Yeah, you can actually save the position data to the actual, so if we say scale 2 and we save that, I think I was ready to, oh, there you go, load. Yeah, the save will save it to, the override will actually save something, but loading will actually modify. So still doing some testing on this, but it's actually looking good. This is a foundation for me for the next step, which is implementing it. So everything uses an interface, so I can call, like on my game manager, I can say, hey, everybody that has an interface can be saved. I want you to give me all your, or I want you to save, call all your functions to save all your relevant state data in scriptable objects, and I'm going to collect those objects in the folder paths, and I'm going to save them to the file. And then, so this allows you to do, like in a build, you save the scriptable objects to a file, and then for actual build, you can load those scriptable objects out of the file, so it's persistent in a build, not just a. It looks like it's persistent in a scriptable object in the editor, but it's not. That's what I learned. So I have to test it in an actual build, but this whole mechanism here allows me to capture the relevant data that I want to save at any given point during the game, and then reload that. So it's coming along, it's looking good, and I'm going to be continuing that. I have the basic framework in place, so that's what I'm going to be doing next week. I'm going to get just a basic framework in place and maybe one or two pieces of data in my character controller to actually save at any given point. Something like maybe position and rotation, or maybe capturing their health at a given time, something like that. So just something basic, but the framework's there and ready to be expanded upon. So I think that's about it. That'd be the last item for the systems epic. Get that working. I have to go back. I have a new epic that kind of, for next sprint, is actually just focusing around a lot of the things that I spotted over this course of testing. There's a lot of issues with like AI head tracking broken, and AI was attacked state that were not looking right. So I want to go back and fix the handful of those things before I proceed on to maybe implementing some more features after that. But that wraps it up for this week. Thanks for joining once again, and we will talk to you later.